Today class we are going to see about the topic on turbine flow meter. So this turbine flow meter is used for measuring the velocity of the fluid. Either they can be in liquid flow or and gas flow that can be measured via using turbine flow meter. Turbine flow meter was invented by Reinhard Voltman. It's an accurate and reliable flow meter for liquid and gases. And the particular meter, which consists of a magnetic multi-bladed free spinning rotor, which is called as an impeller, in line with the flow, and the rotor, which is supported by the shaft that rests on internally mounting support. It is a simple way of measuring flow velocity, and it consists of rotating shaft. It is like an angular blade is placed inside the flow path, and the fluid flowing through the pipeline will cause rotation of the turbine, whose speed of rotation can be a measure of flow rate. That is what the principle. When the fluid is flowing through the pipeline, what will happen? The rotation of the turbine. Because of the turbine rotation, we can able to measure the speed, and the speed of the rotation depends on the fluid flow. So the speed of rotation, it's a measure of the flow rate. This is how we are going to measure using this turbine meter. It's a volumetric measuring turbine type, and it engages the rotor, causing it to rotate at an angular velocity which is proportional to the fluid flow rate. And the angular velocity of the rotor results in generation of electrical signal, and the output of the signal is AC, and the AC signal which is picked up by the pickup coil. So the summation of pulsing electrical signal is related directly to the total flow, and the frequency of signal which relates directly to flow rate, and there is a rotor called band rotor. The band rotor is the only moving part of the flow meter, and moreover your turbine flow meter is used to measure the volume of flowing liquid. So what is the principle? The principle is, which is nothing but the rate of flow of product, which is proportional to the rotor speed. So if there is any change in the viscosity of the fluid, it will affect the meter accuracy. And when you comes for this turbine flow meter, this is how the diagram looks. When the fluid is entering into the path, this is how the construction of the turbine flow meter. So when the fluid enters, this is for flow straightener, and which consists of an blades, and which also consists of an turbine rotor. So when the fluid entering into the flow straightener, what will do? The rotor will get rotate. If the rotor get rotate, already there is an blades, and the blades are made up of magnets, and the turbine blades, generally it is 4 to 8 blades are there. And moreover, here this path we used to call it as an upstream, and this path we used to call it as an downstream. And the upper portion we have a magnetic pickup. What this pickup will do? This magnetic pickup coil picked up by, after once the rotor get rotate, automatically there will be an induction of the AC signal. That signal will be picked up through your magnetic pickup, and this magnetic pickup, via the output of the magnetic pickup, it will create a pulse signal. The pulse signal is nothing but your AC signal, and the signal is again amplified using preamplifier. There is one device called preamplifier, and finally that amplified signal will be getting into electronic counter or flow computer we used to call, and the electronic counter which will be placed inside this part. So the function of electronic counter, which is also called it as a totalizer, this electronic counter will counting the number of pulses. So based on the number of pulses, we can able to measure the speed of rotation of the shaft, and the speed of rotation is directly proportional to the rotor speed, and which gives a value of rate of flow, through which we can able to calculate the viscosity of a particular flow, whether it is in liquid flow or it is in gas flow. And here we have a compensator. That compensator name we used to call it as a viscosity compensator, and the viscosity compensator which was inserted in this particular part. So this viscosity compensator is used for maintaining the relationship between the product of flow rate and the rotor speed to improve the accuracy. So we can able to improve the accuracy using viscosity compensator, and the viscosity compensator device which is also inserted inside the diagram. Then comes to, this is your construction part of the diagram. You can just look at here. There is a material, the magnetic one, which is made up of ferromagnet, that is the pickup coil, through which the signal is picked up. The signal is in the form of sinusoidal. Using the preamplifier and the electronic counter, this signal will be converted into digital pulse, so zeros and ones. And after this, the number of counting pulse will be registered through flow computer. So using this mechanical register, the output of this part will give you the signal. So this path, your upstream and the downstream, when the flow is entering into the line, what will happen? The rotor start rotate. So when the rotor start rotate, there is a blade combinations over there. So when it start rotate automatically, if the flow is induced through the liquid path and the rotor is cutting, automatically there will be an impulse. That impulse will be picked up this particular coil. That coil pulse will be in sinusoidal. After that it will be converted in terms of digital. That is how the signal is captured through your flow computer. Okay. And this is what your turbine blade. Generally these blades are 4 to 8 blades are there. And there is a filtered line fluid. This filtered line fluid is entering through this path, and this is what the coupling of this part, this is called viscosity compensator, and this viscosity compensator purpose is to maintaining the accuracy. That is, whatever the relation you are going to calculate it using product of flow rate and the rotor speed, so that the relation will be maintaining through this viscosity compensator device. So this is called magnetic coupling. If the magnetic coupling is not properly installed, then you can't able to count the number of pulses which was registered in your mechanical register. So this is how the construction diagram looks. So when you are looking here, the rotor sitting on the shaft, which in turn suspend in the flow by two support. As the media flow, a force is applied on the rotor winding. So the rotation of rotor is proportional to the applied force of your flow. The rotor will immediately rotate as soon as the media induce the force. Because of that, the signal will be captured through the pickup coil. So the pickup coil mounting above the rotor, when the plates are passing the pickup, the signal is generated, and that signal using this particular signal, you can able to calculate the speed of the rotor. So from which we can calculate the flow rate. You can just look at here. This is your blade construction. How much angular, that is what WR. So this is how we are going to calculate it, the speed of rotation of turbine, which was measured using optical method or inductive pickup. These are the another two methods for calculating the speed of rotation of the turbine motor. So here WR into capital R by V is equal to tan alpha. So when you are using Pythagoras theorem, using this Pythagoras, you can able to calculate the value of tan alpha, where V is average velocity. You all know average velocity, which is nothing but Q by A. Q is volumetric flow rate and A is effective area of the pipe, and capital R is the radius of the blade what we are going to use. WR, which is nothing but the angular speed of the blade. So this particular expression is related to the volumetric flow rate. So you will have WR, which is equal to KQ. So from this expression, we are just going to calculate the K value, K which is nothing but, because already the WR into R by V, which is equal to tan alpha. So when you are related, you can able to calculate this particular value of your constant value, that is your K. So there is a diffuser inside the device. The diffuser device, which is nothing but diffuser section, which is like you can just look at the construction diagram. This particular path, this is what actually call it as a diffuser. So what is the purpose of this diffuser? The diffuser part, which is used for reducing the velocity and increasing the static pressure of the fluid passing through the system. That is the purpose of the diffuser. So the same expression I am giving once again. I am just going to relate to WR into R by V tan alpha, from which this V we can able to calculate it by the use of the velocity of the fluid. So you want to calculate the average velocity of the fluid, we should know the volumetric flow rate as well as the area of the pipe. Without knowing this, you can't able to calculate it. So the volumetric flow rate we can able to calculate it by the use of this particular expression. And moreover, they are using some variable reluctance motor also. Using this variable reluctance motor, the angular velocity of the rotor, which is equal to geometry of the blade. So through which either you can use the K, which is equal to tan alpha by RA, or else you can use WR into R by V, which is equal to tan alpha, through which we can able to calculate the angular speed of the blade. That is how this is measured. Then advantage, disadvantages of this turbine flow meter. The cost is moderate and it is very good at clean environment, and it is a low viscosity fluid of moderate velocity, and turn down is also very good. They are reliable if you are keeping in the clean fluid, but it is not reliable for steam, as well as there is a bearing wear out. These are the disadvantages. Then comes to limitation part. The limitation, which is it is very less accurate for flow rate due to rotor and bearing drag that slows the rotor. Then only 5% of the maximum flow the turbine we can use it. Above that we can't able to use it, and moreover for high velocity also we can't able to use this. If you are using a high velocity, your blades will get damaged. Then while measuring the fluid, whether you are going for non-lubricating oil, it is very important that we should be careful whether a particular fluid is become inaccurate or whatever it may be, we should be taken care of. Then dirty fluid, that is also should be avoided. For dirty fluids we can't go for turbine flow meter. So there are some moving parts, so automatically they will be subjected to degradation with time and use. So these are all the limitations of turbine flow meter. Thank you. Okay. So I think you would have got a point. The turbine flow meter, it is very simple. Only the blade rotation, you can able to get the value of speed, and the rate of flow of product is directly proportional to the rotor speed. If there is any change in the viscosity, it automatically affect the meter accuracy. So the main purpose of turbine meter is used to measure the volume of the flowing fluid. So using this expression, we can able to calculate the volume. So the principle is depends upon the relationship between the rate of flow of product and rotor speed. That is how it's used. Thank you.